Okay, let's go over the practice test for the second half of chapter 5. The first one we're going to go over is this first graph problem. So there's a picture of a square root graph. Square root graphs do not have a domain of all real numbers or a range of all real numbers. So that's definitely not the correct answer. This point originally started here at 0, 0. So if we have a normal square root graph that looks like that, the domain is x is greater than or equal to 0, and the range is y is greater than or equal to 0. But this graph has changed a little bit. That point that was originally at 0, 0 has moved over 2 and up 3. So on the x-axis, this point has an x value of 2, this next point has an x value of 3, and this point over here has an x value of 6. So all of those x values are 2 or larger, so x is greater than or equal to 2. Because this thing moved right 2, it took that domain, x is greater than or equal to 0, and moved it 2 to the right, so it's now x is greater than or equal to 2. So what do you think the range is going to be? It's not going to be the 0 because it moved up 3. Y is less than or equal to 3 because not only did it move up to 3, it also flipped this graph over. So this first point has a y value of 3. The next point has a y value of 2. The next point has a y value of 1. Those y values are decreasing. If you need to, make yourself a table of points so you can actually look at what the points are doing. This first one is the point 2, 3. The next one is the point 3, 2. And the next one is 6, 1. So you can see that the x values are 2 or larger, and the y values are 3 or smaller. You can see what those x and y values are doing. This next one is a cube root graph. And any cube root graph, regardless of whether it's moved up, down, left, right, flipped, whatever, the domain and the range are always all real numbers. And this is designed in the system so that if you type in all real numbers, capital or lowercase, it should count as correct. Because I don't completely trust the system, I am going to be checking to make sure that if you wrote something about real numbers, it counts it as correct. I think if you write the word real, it will count it as correct. So we'll see. But I am definitely going to be checking this first one individually, because right now this answer is not grading correctly on the practice test, and we actually have an open ticket with EdSite because there's like a problem. So I will be checking to make sure this grades correctly. I will be checking to make sure that that one also grades correctly. All right, let's go down to these 4. Which of these do we need to go over? We're definitely going to go over this one and this one. Okay, this first equation that we need to solve. Your first step will be to get x by itself. So add 4 on both sides. That gives us 5x to the 3/2 equals 40. You have to get x by itself, so divide both sides by 5. How do we undo an exponent of 3/2? Raise both sides to the 2/3. That will give us x equals, and you can just type 8 raised to the 2/3 in your calculator. If you don't know how to put that in your calculator, please see me before the test tomorrow so we can make sure that you do know. You should end up getting 4. And I think on here it already says x equals and then the box, so all you have to do is type in 4. Now, on the test, maybe the problem might look something more like this one. Okay, first of all, do you see how similar the problem I just wrote is to the original problem? That's how we do this with the practice tests and the real tests. Like we do make the problems really, really similar. So if you know what you're doing on the practice test, you're golden for the test. The difference here is that in our original problem, it was raised to the 3/2, and in this one, it's raised to the 2/3. So let's just do this quickly. We would add 4 to both sides. That would make this 32. Then divide by 2. So we end up with x to the 2/3 equals 16. When we raise both sides to the reciprocal, what is the bottom part of that fraction? It's a 2. That means we are taking the square root of both sides. When we take the square root of both sides, we have to put a plus minus in there. 16 raised to the 3/2 in the calculator is 64, so the answer would be positive or negative 64. I will be grading this question as well. Basically, I'm going to have to grade like the first 5 questions individually online to make sure that it grades it correctly. This problem does not require any pre-work. You square both sides, and that gives you 4x plus 11 equals x. We need to get all of our x's onto the same side. So we have 11 equals negative 3x. So x equals negative 11/3. This is the answer that is counting as correct on the practice test. And the issue that I'm about to show you does not exist on the actual test. So the problem with this particular answer, what happens if you replace this x with negative 11/3? You have to do the square root of a negative number, which you can't do. So this practice test problem actually has the answer no solution. Online, it is counting negative 11/3 as correct. So basically what I'm trying to tell you is that the problem on the test, it won't end up being a negative number, so that issue won't exist. So the answer that you get for that problem will be the answer. Make sense? Okay. This one. We need to square both sides. The most common mistake that I see is people try to write x squared plus 16 and think that they have squared the left side. When you do x plus 4 squared, that means x plus 4 times x plus 4. You have to take the time to actually multiply that x plus 4 times itself. So once you just double distribute, combine your like terms, you will end up getting x squared plus 8x plus 16. Now what do I need to do? We need to get it equal to 0. So we subtract x, subtract 6. We have x squared plus 7x plus 10 equals 0. We want this to become 2 sets of parentheses equals 0. So we need to figure out 2 numbers that multiply to give us 10 and add up to 7. And it should be pretty small numbers, like I didn't make them anything crazy on the test. So this is x plus 2, x plus 5. That's the factored form. What are the solutions? -2, -5. Okay, massive test hint. There's room on the test for you to enter 1 answer for this problem. If you try to enter 2 answers for this problem, you will get the problem wrong because one of these answers doesn't work. So we have to check it. If we check -2, what is -2 plus 4? Positive 2. So positive 2 equals the square root of something. That's going to be okay. What if we put negative 5 in right there? We get negative 1 equals the square root of something. The square root always has to equal a positive. This can't happen, so x equals negative 5 can't happen. You would want to only enter the answer x equals negative 2. If you're working on this inverse problem on the practice test, this is the correct answer. It's apparently grading it completely wrong because it has a totally different answer as the correct answer. So call that my bad and Miss Walls' bad, and this is the correct answer for that problem. On these 3 problems, just a couple of things. First of all, with f of x minus g of x, you do have to remember you've got f of x. You have to subtract all of g of x. So you have to subtract the 5x, then you have to subtract the negative 3. You have to subtract both of those terms. So that ends up becoming a positive 3. So your answer should be x squared minus 9x plus 8. A lot of people get this part wrong because they forget to subtract the second term. On the practice test, it's asking you to do f of g of x, but I am going to really strongly suggest that you actually do g of f of x because maybe that is more similar to how it's going to look on the test. So if we do g of f of x, we're going to do g of, and I think these colors really help, f of x. When you do g of f of x, you are taking the x out of the g function. So the g function is 5 times something minus 3. Take that x out and put parentheses in. Inside those parentheses, you're going to put the entire f function, x squared minus 4x plus 5. Now you need to distribute. And then combine like terms. Both of these have a domain of all real numbers. When in doubt, the domain is all real numbers. There's only a few instances where the domain is not all real numbers. And one of those instances is the division problem that we are going to do next. In that division problem, f of x is x squared minus 4x plus 5. G of x is 5x minus 3. That is your answer for that problem. It's the easiest problem on the test. You don't have to do anything. Just put the f function on the top, put the g function on the bottom. But the domain is not going to be all real numbers. Think about when would the bottom equal 0. So put 5x minus 3 equals 0. Solve that equation. So when x is 3/5, the bottom is going to equal 0. The bottom can't equal 0, so x can't equal 3/5. So put the bottom equal to 0, and then your domain is x can't be that thing. Okay, I think I'm gonna stop this video here. Watch the next video to get the second half of the practice test.